Hi students, welcome to the channel Kerala Neet Academy. Welcome to the new program Neet 15 Days Mission. My name is Mohan. I deal with the subject physics. Today we are going to discuss some simple and important numericals from the three topics, namely units and dimensions, one-dimensional motion and two-dimensional motion. Before we switch over to the part of solving these numericals, let us revisit some important concepts in the topics one-dimensional motion and two-dimensional motion. If you come to the part of one-dimensional motion, we have to focus on three areas, namely average and instantaneous values, kinematic equations, including gravity, and graphical representations. If you come to the case of two-dimensional motion, totally three parts are there. One is complete vectors, second projectile motion, third one will be kinematics of circular motion. Now let us start with one simple idea from the one-dimensional motion. First of all, let me give some basic idea relating to average values and instantaneous values. So there is a fixed relationship between average value of a physical quantity and instantaneous value of a physical quantity. In different chapters, we are having different values of average and instantaneous. And the relationship between average value of a physical quantity and instantaneous value. Average value of a physical quantity will be equal to integral instantaneous value a bar into dt divided by integral dt. Suppose a bar is one physical quantity. It may be either velocity, acceleration, or even scalar quantities also we can take. Then the average value of that physical quantity will be given by this generalized equation. In this equation, a bar represents the instantaneous physical quantity. If instantaneous physical quantity remains constant, from this equation that a bar will be taken out of the integration, integral dt divided by integral dt we are getting. Therefore, average value of the physical quantity will become equal to instantaneous value for any interval of time. For example, if you take an example of what we call velocity, if a velocity of a particle remains constant, then for any interval of time, average velocity of the particle is equal to instantaneous velocity. Say for example, a particle is projected into gravity at an angle theta with the horizontal, say for example. Then we know that this particle moves along a parabolic path. Suppose time of flight of this particle is, say for example, 10 seconds. And they are asking us to calculate average acceleration of this particle, projectile, during a time interval from some 3 seconds to 4 seconds. See, we know that as the particle is moving under gravity, the acceleration of the particle is nothing but acceleration due to gravity, which remains constant. As acceleration is constant for any time interval, whether it may be 3 seconds to 4 seconds or 1 second to 5 seconds, average acceleration of the particle will be equal to instantaneous acceleration, which is nothing but acceleration due to gravity. That means if you come to know that the physical quantity is constant, no need to calculate the average value of that physical quantity separately. Average value always will be equal to instantaneous value, no doubt in that. And if you come to the case of especially average velocity, generally students they express one kind of question. Average velocity of a particle can't we express as initial velocity plus final velocity by 2? This is the common doubt expressed by majority of the students, not only in case of velocity. If they want to calculate any average value of a physical quantity, they ask Shall we add initial plus final by 2 like that? Okay. Actually, for average value of a physical quantity can be calculated by using this type of equation, like arithmetical mean. Initial value plus final value by 2 we can take, provided with one condition. If that physical quantity is linear physical quantity. Example, when a particle is moving with some constant acceleration, we know the equation for velocity as v is equal to u bar plus a bar into t. This is the kinematic equation, you are very much familiar. So in this equation, this velocity v bar is a function of time t. So velocity is a linear physical quantity. If any physical quantity is linear physical quantity, then the average value of that physical quantity can also be written as initial plus final value by 2. Therefore, average velocity, you can use this equation when particle is moving with constant acceleration. Because of this reason, you might have practiced one of the kinematic equations as displacement covered by the particle is equal to average velocity into time interval. So, average velocity is nothing but u bar plus v bar divided by 2 into t. This equation you can use for calculation of what we call average velocity. Okay, now come to the next point. Come to the case of kinematic equations. When a particle is moving with constant acceleration, we are having different kinematic equations. Already you have practiced. You are very much familiar with all these equations. V bar is equal to u bar plus a bar into t. Second equation, S bar is equal to u bar into t plus half a bar into t square. V square minus V square is equal to 2 into a bar dot S bar. Sn bar will be equal to u bar plus a bar by 2 into 2n minus 1. And one more equation also you can take. Displacement covered by the particle will be equal to average velocity of the particle into time taken. Okay. See here, majority of the students, they are having one misconception. See, if you look at this second equation, it is S bar is equal to u bar into t plus half a bar into t square. Remember, these kinematic equations are vector equations. So in all these equations, that S bar actually it represents displacement covered by the particle. So by using kinematic equations, actually in fact we cannot calculate distance covered by the particle. By using kinematic equations, we can calculate only displacement covered by the particle. You should be really very, very careful regarding this particular point. When we discuss numericals from the part, I will give you the complete idea of this particular equation, what I have been explained now. So, we can use these kinematic equations in relative frame also. If the relative acceleration between the particles remains constant, you can use these equations in relative frame like final relative velocity is equal to initial relative velocity plus relative acceleration into time taken. Likewise, you can take other equations also in relative frame. Then how do we use these kinematic equations in deriving different physical quantities? Just 2-3 simple examples I will explain. Just listen to the parts. Okay. Just 3 examples, I make some comparison. Suppose a particle is projected vertically upwards with some speed u from the ground. This is the first case. Second case is a particle is projected obliquely from the ground at an angle theta with the horizontal. This moves in a parabolic path like this. And take one more example, like a particle which is projected horizontally from the top of the tower with some speed u like this, third case. Okay, then how do you use these vector equations in getting different physical quantities? Just as an example, first two equations I will explain. V bar is equal to u bar plus a bar into t. You are very much familiar with unit vectors. If you express these physical quantities in unit vectors, very easily you will get the final physical quantities. In this case, if you take an example of this what we call vertically projected body, in this case initial velocity will be equal to u j cap. And in all these three cases, the acceleration of the particle is nothing but g minus j cap, because acceleration is acting downwards. We can represent with a unit vector minus j cap. Okay, by using these unit vectors, let us find out the final velocity of these particles in these three cases after time t. In the first case, final velocity of the particle after time t will be given by u bar is nothing but u into j cap plus a bar is nothing but g into minus j cap into t. Therefore, this will be equal to u minus gt j cap. This is the first equation. This is in the first case, a vertically projected body. Even in case of an obliquely projected body, or even in case of horizontal projection from the top of the tower also, very confidently you can use these kinematic equations, because acceleration remains constant. As long as acceleration is constant, very confidently you can use the kinematic equations what I have discussed. So if you come to the second case, after some time t, the location of the body will be somewhere like this. At this point, the velocity of the particle will be v bar. But in this case, initial velocity of the particle is having two components. One component along x-axis is u cos theta, and one component along y-axis will be u sin theta. Therefore, in case of oblique projection from the ground, initial velocity of the particle can be taken as u cos theta I cap plus u sin theta j cap we can write. This is initial velocity. And acceleration is nothing but acceleration due to gravity in all the three cases, which is acting vertically downwards, so minus j cap. So by substituting u bar and a bar in the basic equation, v bar is equal to u bar plus a bar into t, then we can write as v bar is equal to u cos theta I cap plus u sin theta j cap plus g minus j cap we are getting, g minus j cap. By rearranging these factors, we can write it as u cos theta I cap plus u sin theta minus gt j cap we are getting. So from this equation it is very clear. The final velocity of this particle in case of an obliquely projected body from the ground will have two components. One component is along what we call positive x-axis, which is nothing but u cos theta I cap, and one component along y-axis nothing but u sin theta minus gt. In similar way, in the third case also, we can apply the same equation to get the velocity of the particle. Come to this third example. Horizontal projection from the top of the tower case. Suppose particle is projected with a speed u like this from the top of the tower. After some time, the location of the particle will be somewhere here. So the velocity of the particle at this instant will be v bar. Same kinematic equation we can use. V bar is equal to u bar plus a bar into t. In this case, u bar is nothing but u I cap. Velocity is along positive x-axis. And acceleration of the particle will be equal to g minus j cap. So by substituting these conditions in this above equation, it will become V bar will be equal to U I cap plus G minus J cap into T. Therefore, this will be U I cap plus GT minus J cap we can write. This is V bar. That means after time T, just like in the previous case, here also body will have two components. One component along x-axis, nothing but U. Another component along negative y-axis, it is nothing but GT. So if you look at this particular diagram, at this point, horizontal component of velocity will be U and the vertical component of velocity will be GT. Okay, it is a very simple, very easily you can practice this. Likewise, all other physical quantities also. If you want to calculate displacement covered by the particle in time t, you can use the second kinematic equation. S bar is equal to U bar into T plus half A bar into T square. U bar and A bar from this data you can substitute in the above equations. Okay. Come to the next point. See, in the part of what we call one-dimensional motion, already I told you have to focus on three areas, and the third part will be graphical representations. Brief idea I will give you relating to different kinds of graphical representations. See, various graphs already have studied. Displacement time graph. Second, velocity time graph. Third one will be acceleration time graph. Sometimes questions may also be given from other parts of the graphs also. Safe side, if you are interested, you can practice these graphical representations also. Velocity displacement graph, square of velocity displacement graph, acceleration displacement graph. Okay, briefly let us look at all these different kinds of graphs. From these graphs, what physical quantities do we get? Let us see. If you come to the case of displacement time graph, slope of this graph represents velocity of the particle. You are very much familiar. If you take velocity time graph, slope of this graph represents acceleration of the particle, and area under the graph represents displacement. So from velocity time graph, two factors we can calculate. Come to acceleration time graph. We are having significance of area only in this case. So area under the acceleration time graph, it represents change in velocity of the particle, final velocity minus initial velocity. If you come to the other graphs, like velocity displacement, you are very much familiar with one particular equation. Acceleration of a particle can be written as V into dV by ds. It is one of the equations we are having in our syllabus. So in this case, dV by ds represents slope of this velocity displacement graph. Therefore, if a velocity displacement graph is given, from that graph, if you calculate slope, that slope represents the ratio between acceleration and velocity of the particle. Now come to the case of V square displacement graph, square of velocity and displacement graph. We can write dV square will be equal to 2a into ds for small changes. Therefore, dV square by ds. dV square by ds. If you think that dV square by ds from this equation, it will represent 2a value. Therefore, if V square displacement graph is given, then the slope of the graph represents twice the acceleration of the particle. This is V square displacement graph. Come to the last graph, it is between acceleration and displacement graph. For this also, we are having significance of area. Area under this particular graph represents V square minus U square by 2 value. So these are the various graphical, main graphical representations which must be practiced. Okay. Now come to the case of one very important concept relating to vector applications, nothing but relative velocity. Very often I have seen students, they are undergoing confusion regarding especially applications like motion of a boat in a river and rain related numericals. So let us look at the detailed explanation of this particular part. See, you are very much familiar that relative velocity of body A with respect to body B will be given by velocity of the body A minus velocity of the body B. You are very much familiar. Not only relative velocity, any other relative quantity will be calculated like this. Displacement of A with respect to B will be equal to displacement of A minus displacement of B. That's it. It's a standard equation we are having. Now come to the case of motion of a boat in a river case. Here generally several times I have seen students generally they ask one question. In case of motion of a boat in a river, do we calculate relative velocity or resultant velocity? This is the common doubt expressed by majority of the students. Okay, now let us make the interpretation of this particular case. Suppose you just imagine one river is flowing along positive x-axis with a velocity, say for example VR bar, and one man has started at one side of the bank at point A, at one bank of the river, and he has to reach the other bank of the river. Whenever you please remember, all of you dear children, when one body is moving over the other body, unless until we define velocity of one body with respect to the other body, we can't calculate the absolute values. Okay, I make the point more clear. In this particular case, if you do not define velocity of the boat with respect to the river, we cannot calculate the velocity of the boat with respect to the ground. Okay, so initially let us define in some arbitrary direction velocity of the boat with respect to the river like this. Okay, and let us assume it is making some angle theta with the vertical. Now general relative velocity equation we can take here. So velocity of the boat with respect to the river is equal to velocity of the boat minus velocity of the river we are having. See, in this equation VB bar represents velocity of the boat with respect to the ground. In fact, we are interested in that particular part. VR bar represents velocity of the river with respect to the ground. So from this relative velocity equation, if you want to calculate velocity of the boat with respect to the ground, we should write like this. Velocity of the boat is equal to velocity of the boat with respect to river plus velocity of the river. It is very clear. So here both ideas are actually included. The idea of relative velocity is included and the idea of resultant velocity is also included. Resultant velocity means velocity of the boat with respect to the ground is the resultant of two velocities. One is velocity of the boat with respect to the river and the second one is velocity of the river. That's it. Okay, now let us express velocity of the boat with respect to the river in unit vectors and velocity of the river also in unit vectors. Okay, if you resolve velocity of the boat with respect to the river, see, you remember here one more important point is also there to be practiced. Velocity of the river with respect, velocity of the boat with respect to the river is also named as velocity of the boat in still water. It is really very, very important point which must be practiced. Sometimes in numericals, rather than giving velocity of the boat with respect to the river, they may give velocity of the boat in still water also. Both are nothing but one and the same. You should be very careful regarding this particular point. Okay, now let us resolve this velocity of the boat with respect to the river into the two components from this diagram. If you look at the diagram, one component in vertical direction will come out to be VBR cos theta and another component is nothing but VBR sin theta. So one component is along positive y-axis and other component is along negative x-axis. Therefore, velocity of the boat with respect to the river will be given by VBR sin theta minus I cap plus VBR cos theta j cap. This is the velocity of the boat with respect to the river. Velocity of the river in this example is defined along positive x-axis. Therefore, velocity of the river will be equal to VR I cap. Okay. Now, let us substitute these two equations in the above equation of velocity of the boat. Velocity of the boat, already you have seen. Velocity of the boat means it is the velocity of the boat with respect to the ground. Okay, it is a resultant of these two velocities. Those two velocities we can add now. Then by adding these two velocities, you will get VBR sin theta minus I cap plus VBR cos theta j cap plus VR I cap we are getting. Therefore, the net velocity of the boat with respect to the ground, if you rearrange these factors, VR minus VBR sin theta I cap plus VBR cos theta j cap. It is very clear. Okay. See, if you look at this particular equation, velocity of the boat with respect to the ground is having two components. One component is along positive x-axis, I cap. Other component is along y-axis. Okay, now let us make some interpretation from this particular equation. So, to which point that boat has to reach on the other side, other bank of the river, it depends mainly on the comparison between VR and VBR sin theta factors. See, from this equation it is very clear, if VR and VBR sin theta, if these both factors are equal, then x component of velocity of the boat is becoming 0, then boat moves straight along y-axis. That means, in order to reach exactly the opposite point on the other bank of the river, the main condition from this particular equation is VR should be exactly equal to VBR sin theta. It's very clear. Okay. Suppose if VR is dominating than VBR sin theta factor, just look at that equation, you will understand. If VR dominates than VBR sin theta, then velocity of the boat with respect to the ground will have two components now. One along positive x-axis, other along positive y-axis. In such case, the resultant motion of the boat will become like this. Then the resultant motion of the boat will come like this. When VR equals to VBR sin theta, there is no drift on reaching other bank of the river. It will reach exactly opposite points. See, just look at this diagram. AB, exactly opposite point B it will reach. If VR is greater than VBR sin theta, then the net velocity is coming along positive x-axis, one component. Other component as it is. Other component will be VBR cos theta. Whether the boat may be reaching exactly opposite point or any other point on the other bank of the river, there is no change in the vertical component of velocity. It remains constant. VBR cos theta remains constant. Only x component is changing. It all depends upon the comparison between VR and VBR sin theta. So just now we have seen when VR is dominating than VBR sin theta, then that boat will reach the point C. Just look at this diagram. It will reach point C like this. That means it will undergo some kind of drift along positive x-axis. Similar way, if VR is less than VBR sin theta, then the x component of velocity of the boat will be negative. So in this case also it will not reach exactly opposite point. In this case it will reach some other point like this, D. So it all depends upon the comparison between VR and VBR sin theta. And one more important point also let me discuss here relating to this motion of a boat in a river. Just look at this diagram, all of you. Okay. This representation of angles, they are very important. This is velocity of the boat with respect to the river, we defined. This is the angle theta. See, some directions you can visualize like this also. East, west, and north and south directions. Okay. Here it is making an angle theta with vertical direction, means with the north direction. Then we can say this angle as, this angle theta, we can say it as west of north, west of north. Suppose this angle is, say for example, alpha. If you want to define that alpha, we call it as north of west. West of north means it is the angle made by VBR bar with north direction. North of west means it is the angle made by VBR bar with west direction. In recent NEET entrance examination also one question has given related to these directions. So that time I will give you the complete clarity. So in this case you please remember whether that boat may be reaching exactly opposite point or any other points like this. The vertical component of velocity VBR cos theta remains constant. Therefore, the time taken by the boat to cross the river we can calculate by taking the help of that vertical component of velocity. Suppose W is the width of the river, say for example. Actually, in a two-dimensional motion, by taking the help of either horizontal and vertical direction, you can calculate the time taken by the body. So, if you want to calculate the time taken by the body to reach exactly, to reach any point on the other bank of the river, T will be equal to W by velocity in that particular direction you can take, which is nothing but VBR cos theta. Okay. So this is a general equation for the time taken by the boat to cross the river. Okay. Here actually generally for medical entrance examinations, two cases are very important. To cross the river in the shortest path and to cross the river in the shortest time. To cross the river along the shortest path already we have discussed. So in order to reach exactly opposite point, the main condition is VR will be equal to VBR sin theta is the main condition already we have discussed. Okay. And one more important point which must be practiced is whether the boat may be reaching other bank of the river in the shortest path or in shortest time or in any other case, that basic equation what we have studied must be satisfied. Okay, just look at this diagram. Suppose first of all let us consider it is reaching the exactly opposite point. So with this condition VR will be equal to VBR sin theta. This is VBR bar. This is VR bar and this will become VB bar. Already we have seen VB bar, velocity of the boat with respect to the ground. It is the resultant of two velocities. One is velocity of the boat with respect to the river and the second one will be the velocity of the river. So triangle of addition of vectors has to be satisfied here. So if you look at this particular diagram, VB bar is the resultant of the remaining two velocities. Remaining two velocities means VBR bar and VR bar. Now it is reaching exactly opposite point. Now come to the case of the boat reaching the other bank of the river in the shortest time. See, general equation for the time taken by the boat to cross the river already we have seen. T will be equal to W by VBR cos theta. So for this time to become minimum, from this equation it is very clear this cos theta value should become maximum. And the value of cos theta become maximum when theta will be equal to 0 degrees. See, theta in this example we have defined angle made by VBR bar with vertical we defined. VBR bar with vertical. So theta is equal to 0 means that VBR bar should come perpendicular to the bank of the river like this. That means if the boat is rowed in that particular direction, then it will not reach exactly opposite point, but it will reach some other point with some drift but it will reach the other bank of the river in the shortest time. So here VB bar is the resultant of VBR bar and VR bar. Again, triangle of addition of vectors we can try here. This is VR bar, this is VBR bar, this is VR bar. So the resultant of these two will come like this. This is VB bar. That means that boat has started from point A at one bank of the river. It is reaching the other bank of the river at point C. That's it. So these are the two cases which must be practiced very carefully. Sometimes in examination they may ask us to find out these angles with downstream and upstream also. Just one point let me discuss here, after that we can switch out to the other part. Suppose here VB bar, velocity of the boat with respect to the river, is making an angle theta with vertical. Suppose this angle theta is say for example we are getting it as 30 degrees. Say for example, if it is 30 degrees means with alpha, in this case alpha will become 60 degrees. That means velocity of the boat with respect to the river is making an angle alpha 60 degrees with upstream, we say upstream. If you want to express this angle with downstream, this is the angle it will come. This total angle is with downstream, means 30 plus 90 degrees, 120 degrees with downstream. Actually theta we defined with vertical, that angle theta we defined with vertical. Upstream it is making some angle 60 degrees, and downstream it is making an angle of 120 degrees. In different ways they may ask us to express this part. Okay. Okay, now come to the case of circular motion. Okay, before that circular motion, one simple point let me discuss relating to this rain problems as an application of this relative velocity. So if it is the case of rain, also it is an application of relative velocity. Velocity of the rain with respect to the man will be equal to velocity of the rain minus velocity of the man. This is the equation we are having. Suppose initially let us assume it is raining vertically downwards at one place, and here one man is standing at that place. Man is stationary. For that stationary man, rain appears to be hitting vertically downwards. Okay. Suppose if this man moves in the forward direction, in which direction that rain appears to be hitting that man, let us identify. If he moves in the backward direction also, let us see these two cases. When this man moves in the forward direction, okay, here from this equation we are having velocity of the rain with respect to the man will be equal to velocity of the rain minus velocity of the man. The same equation we can write it as velocity of the rain plus minus velocity of the man. Suppose man is moving in the forward direction, minus Vm bar will come in the backward direction. This is minus Vm bar. Okay. If magnitude of Vm bar is V, the magnitude of minus Vm bar also will become V. Okay. Here Vrm bar is the resultant of two velocities. One is Vr bar and second one will be minus Vm bar. So that resultant will come like this. So this is nothing but velocity of the rain with respect to the man. Velocity of the rain with respect to the man. That means when man is moving in the forward direction, that rain appears to be tilted away from him in the opposite direction. Similarly, if man is moving in the backward direction, that rain appears to be tilted in opposite direction to that man. This is a very important point which must be practiced here. Okay. When we solve numericals, I will give you the complete idea of this particular application. This is a simple point to just practice. Now come to the case of kinematics of circular motion. In case of kinematics of circular motion, very often I have seen the students they undergo confusion relating to the vector relationship between linear variables and angular variables. Just 2-3 simple points let me discuss here. See, suppose if a particle is rotating in anti-clockwise direction, for a particle which is rotating in anti-clockwise direction, the direction of angular displacement is perpendicular to the plane upwards. This is the convention. Similarly, the direction of angular velocity also will come in the same direction. Omega bar also will be upwards. That angular acceleration alpha bar, it depends upon actually the torque experienced by the particle. Anyhow, if that alpha bar is along the direction of omega bar, then the particle will accelerate. Angularly it is accelerating. That means angular velocity will increase. If alpha bar is opposite to that what we call omega bar, then the particle will undergo angular retardation. It is very clear, very simple. And one simple point which must be practiced here is for one particular sense of rotation, the direction of that particular physical quantity like angular velocity, it remains constant. It won't be changed. In most of the situations in this particular chapter, whenever they have given that angular velocity is changing means it is generally that change is related to magnitude of angular velocity. Okay, first of all, let us look at the vector relationship between what we call linear variables and angular variables. All these relationships are very important. S bar will be equal to theta bar cross r bar. All these are examples of cross product of vectors. And linear velocity v bar will be equal to omega bar cross r bar. At bar will be equal to alpha bar cross r bar. At bar means tangential acceleration. After completion of this part, a brief idea I give you relating to uniform circular motion, non-uniform circular motion. Then you understand the differences between tangential acceleration and radial acceleration. And radial acceleration will be given by omega bar cross r bar. These four relations you just remember. Sorry, it is not omega bar cross, it is omega bar cross v bar. Omega bar cross v bar. Okay. And if you come to the case of one simple point I tell you, with that I conclude all these concepts. If you come to the case of what we call uniform circular motion, in uniform circular motion, the particle is acted only by one type of acceleration, which is nothing but radial acceleration. Another name of radial acceleration is centripetal acceleration. So if you consider uniform circular motion, in uniform circular motion, the speed of the particle remains constant. Only direction of velocity is changing. To change the direction of velocity, one acceleration is required, which is nothing but centripetal acceleration. It's a very simple point. If you come to the case of non-uniform circular motion, totally two accelerations will be there. One acceleration is in the plane of the circle. Another acceleration is perpendicular to the plane of the circle. So the acceleration which is in the plane of the circle is a bar. It will have two components. One is tangential acceleration, which will be helpful to change the speed of the particle. Another one will be radial acceleration, which is also named as centripetal acceleration. Okay, so the resultant of these two accelerations in the plane of that circle will be given by root of at square plus ar square. These two accelerations are totally independent. Here, centripetal acceleration will be helpful only to change the direction of velocity of the particle in circular motion. It doesn't have capacity to change the speed of the particle. Tangential acceleration will be helpful only to change the speed of the particle, nothing but magnitude of velocity of the particle in the circular motion. It doesn't have any connection with changing the direction of velocity of the particle. Okay, this is the simple point which must be practiced. So, if the circular motion is non-uniform circular motion, in that non-uniform circular motion, in the plane of the circle, acceleration is a bar. Along with this acceleration a bar, one more acceleration also will be there, which will come to the perpendicular to the plane of the circle, nothing but angular acceleration. Okay, these are the simple points we have revisited. Okay, now let us discuss some simple numericals by connecting all these concepts. Okay. See, this is the question from units and measurements. This question has given in 2021 Neet entrance examination, especially relating to units and measurement, majorly on three areas we have to focus. One is a dimensional formula, anyhow we have practiced. Along with that errors part, calculation of errors, and these instruments like vernier calipers and screw gauge. Okay, this is one of the simple numerical relating to the construction of the screw gauge. Just look at this particular question. A screw gauge gives the following readings when used to measure the diameter of a wire. Main scale reading is given what we call main scale reading is given 0 millimeters. Circular scale reading is given 52 divisions. Given that 1 millimeter on main scale correspond to 100 divisions on the circular scale, the diameter of the wire from the above data they are asking us to find out. Okay, so if you come to the case of screw gauge, that the diameter of the wire, final reading, diameter of the wire will be given by general formula already have practiced, main scale reading plus circular scale reading into least count. This is the equation we are having. If you come to the case of vernier calipers, similar way, final reading will be given by main scale reading plus vernier scale coincidence into least count. These two formula thoroughly just practiced. Okay, here main scale reading they have given 0 millimeters plus circular scale reading they have given 52 into least count. So least count also very easily you can calculate from the data what they have given. In case of the screw gauge, least count will be given by pitch of the screw divided by number of head scale divisions. Pitch of the screw by number of head scale divisions. So pitch of the screw is nothing but 1 millimeter divided by number of head scale divisions they have given as 100. Therefore, this will become 0.01 millimeters we are getting. By converting into centimeters, it will become 0.001 centimeters we will get. 0.001 centimeters. Okay. By substituting this value of least count in the first equation and solving this, you will get the answer as 0.052 centimeters you will get. This is the question which has given in 2021 Neet examination. Come to the next question from the same topic. Usually students they express a doubt relating to this particular part, especially relating to resistances. Here it is given two resistors of resistances 100 plus or minus 3 ohms and 200 plus or minus 4 ohms connected in series and in parallel. Find the equivalent resistance of the series combination and the parallel combination. As far as series connection is concerned, calculation of those errors, delta R value will be very simple as it is addition. If you come to the series combination, in series combination, equivalent resistance will be given by R1 plus R2. So it is addition. Therefore, in this case, final equivalent resistance, in case of addition, that delta R value will be directly given by delta R1 plus delta R2. And in series, R effective is nothing but R1 plus R2. So directly you can add these values. Here R1 is given 100 ohms and R2 is given 200 ohms. Therefore, R effective in series combination is nothing but 300 ohms plus plus or minus. Here delta R1 is nothing but 3 and delta R2 is nothing but 4. Therefore, total error in the measurement of R in case of addition will be given by the equation delta R1 plus delta R2, nothing but 7. This is the total resistance in series. If you come to the parallel combination, 1 by Rp will be equal to 1 by R1 plus 1 by R2. So this will be equal to, by substituting this R1 and R2 values, 1 by 100 plus 1 by 200. By solving this, you will get this one as nearly 66.7 ohms you will get. Rp, resistance in parallel combination. Okay. If it is the case of 1 by R1 and plus 1 by R2, very carefully you have to calculate that error in the measurement of R. Error in the measurement of R will be given by delta Rp divided by Rp square will be equal to delta R1 divided by R1 square plus delta R2 divided by R2 square. By simple differentiation, you will get this idea. Okay. From this, error in the measurement of resistance in parallel combination will be given by Rp square into delta R1 divided by R1 square plus delta delta R2 by R2 square is the equation we are having. Rp value already we have identified, already we calculated. By substituting that Rp value, delta R1 is given 3 ohms, delta R2 is given 4 ohms. By substituting all these values, by solving delta Rp will come out to be 1.8 ohms. Therefore, the total equivalent resistance in parallel will be given by 66.7 plus or minus 1.8 ohms we will get. Now come to the next question. Okay, just look at this question. A particle starts with a velocity of 10 meter per second and a deceleration of 5 meter per second square. Find the distance covered by the particle in 6 seconds. They are asking us to find out. Very clearly, already I have explained that by using kinematic equations, we can calculate only displacement covered by the particle, but not distance covered by the particle. You should be very careful. Okay. In this particular question, actually they are asking us to find out distance covered by the particle in time 6 seconds they are asking. Okay. By using the kinematic equation, let us calculate displacement covered by the particle. After that we will see. Suppose see in this particular case, particle has started from the origin, you can think. This is the origin, which is projected along positive x-axis with a speed 10 meter per second. And this particle is undergoing retardation, deceleration. That means the direction of acceleration of the particle is along negative x-axis. That value they have given as 5 meter per second square. Okay. No doubt in this particular example that the particle is undergoing retardation, means velocity of the particle gradually decreases until it becomes 0. From that point it starts moving in the backward direction. Okay. Without all these points blindly, let us substitute this data in the standard equation and let us find out displacement covered by the particle. So displacement covered by the particle, we know that u bar into t plus half a bar into t square is the equation we are having. Okay, it is very clear. U bar value we can define as positive, means positive x-axis we are defining a positive, and the negative x-axis we can define it as a negative. Okay, so u bar is positive 10 into time is given 6 seconds. 6 seconds we are calculating this. plus half into, acceleration is along negative x-axis. As we have defined positive x-axis as positive, this will become automatically negative, minus 5 into t square, nothing but 36. Okay. Therefore, S bar will be equal to 60 minus 90 we are getting. So that will be equal to minus 30 meters we are getting. Okay. What does it mean? Here, particle is projected along positive x-axis. It is undergoing retardation. After 6 seconds, the location of the particle is at 30 meters from the origin. We got it as negative. In this equation, this minus indicates, in this case, that negative sign indicates the final displacement covered by the particle is along negative x-axis. So particle has started at the origin O, started at O. Now, it has started at point O. Now final displacement we got it as minus 30 meters. That means after 6 seconds, the location of the particle is somewhere here, which is 30 meters away from the origin. That is the meaning. But in this case, they are not asking us to find out the displacement covered by the particle. They are asking us to find out the distance covered by the particle. Then how do you calculate that distance? So it is very clear. Be careful, all of you. By using kinematic equations, we can calculate only displacement covered by the particle, but not the distance. Okay. Here, particle has started from point O with the speed 10 meters per second. After traveling through some distance, it will come to rest. Okay. After traveling through how much distance it will come to rest, if you know that distance, then we can calculate the total distance covered by the particle. See, particle has started from point O. Suppose it is coming to rest at point A, and finally after 6 seconds, the location of the particle is at point B. Therefore, the total distance covered by the particle is nothing but OA plus AO plus OB is the total distance covered by the particle. S is equal to OA plus AO plus OB, nothing but 2OA plus OB. Then the distance covered by the particle from O to A very easily you can calculate. You just compare this just like a body projected vertically upwards, the maximum height attained by a body, relatively just think u square by 2g. So in this case, the total distance covered before coming to rest will be given by u square by 2a. By using kinematic equation only, we will get this part also. U square is nothing but 100 into 100 divided by 2 into a value is given 5. This is nothing but u square, sorry, here I committed one mistake. U square is nothing but 10 into 10 divided by 2 into the acceleration value is 5. So this will be 10. Okay. 10 meter after traveling through a distance of 10 meters, after traveling through a distance of 10 meters, it will come to rest. That means OA distance. OA is 10, AO is also 10, 20. From that, another distance will be 30. OA is 10, we got. So this is 20, other one will be 30. Therefore, total distance covered by the particle during this process will be equal to 50 meters. 50 meters will be the answer. Come to the next question. This question has given in the recent Neet entrance examination 2022. The ratio of the distances travelled by a freely falling body in the first second, second and third second and fourth seconds will be. So in case of a freely falling body, initial speed of the particle will be equal to 0. So distance covered by the freely falling body in the nth second will be given by Sn will be equal to, directly you can write g by 2 into 2n minus 1. Therefore, Sn is proportional to 2n minus 1. They're asking us to find out that distances. See, if there is no change in the direction of the particle, without changing in the direction of the particle, if a particle is going along a straight line path, distance covered by the particle is always equals to magnitude of displacement. In such cases, you don't get much problem. But in the previous numerical, their displacement and distance differences, I think you have understood very clearly. Come to this part, the particle is falling downwards. So Sn is proportional to 2n minus 1. In first second, second second, third second, fourth second, they are asking us to find out. So S1 is to S2, S3 is to S4. If you keep n is equal to 1, it will become 1. If you keep n is equal to 2, it will become 3. If you keep n is equal to 3, 5 is to 7. 1 is to 3 is to 5 is to 7. This is the question given in the last NEET entrance examination. So second option will be the answer for this particular question. Come to the next part. The displacement time graphs of two moving particles make angles of 30 degrees and 45 degrees with x-axis as shown in the figure. The ratio of their respective velocities they are asking us to find out. Already we have seen the slope of this displacement time graph represents velocity of the particle. So, so in this case, the ratio of the slopes, velocity of the first particle divided by velocity of the second particle will be equal to ratio of the slopes. Ratio will be given by tan theta. So this will be tan 30 degrees divided by tan 45 degrees. So this will be 1 by root 3 by 1. 1 is to root 3. This question also has given in the last NEET entrance examination. Okay. Come to the next question. Look at this part. It is also one simple example. It is the graph given. In this case, it's a graph given between acceleration and time. The maximum velocity attained by the body, they're asking us to find out. We know that the area under acceleration time graph represents change in velocity of the particle. Therefore, from this particular example, from this particular graph, area under the graph will be given by half into base is given 11, that time is given in seconds and acceleration is given in meter per second square. So area under the graph is nothing but half into base into height. Therefore, from this equation it is very clear the total area under the graph 55 units. So the area under this acceleration time graph represents change in velocity of the particle, and it is given very clearly. And one more information also should be given in the question, that initial velocity, that particle if it starts from rest, that should be given. So v minus u is the 55 units. If the particle starts from rest, u will be equal to 0. Therefore, the final velocity of the particle will come out to be 55 meter per second. This is one of the examples for this graphical representations. Come to the next question. See, this example I have selected to explain the concept of kinematic equation in relative frame. Just look at this question, all of you. An elevator in which a man is standing is moving upwards with a constant acceleration of 1 meter per second square. A stone at an instant when a stone is actually released, misprinting is there in the question. A stone is released when the speed of the elevator is 10 meter per second. No, it's clear only. At some instant when speed of the elevator is 10 meter per second, correct only, the man drops a coin from a height of 2 meters. Find the time taken by the stone to reach the floor of the lift, they are asking us to find out. Okay, then how do we handle this one? We can solve this question either from the ground frame or from the lift frame. Okay, now I solve this question from the lift frame of reference. That means by taking kinematic equation in relative frame. Just look at this example, all of you. Here lift is moving upwards and also accelerating upwards. At one instant, let the speed of the elevator is, say, for example, u. At that instant, a stone is released from some height 2 meters inside the lift. A man is standing inside the lift, just imagine. From 2 meters height, a stone is released. So, here, as soon as that stone is released, that stone gets the same velocity as that of the lift. Here, lift velocity we assumed u upwards. That is the case given. Therefore, as soon as that stone is released, that u will be upwards. Here also one common doubt, majority of the students they express. So you remember, whenever a body is released like this, by inertia, only velocity of that frame will be transferred to that particle, but not acceleration. You should be very careful here. Acceleration will not be transferred, only velocity will be same. So as soon as that stone is released, the velocity of the stone is the same as that of velocity of the lift. And now that stone is falling under gravity. So it will have acceleration g downwards. It is having acceleration downwards. Okay. They are asking us to find out how much time that stone will take to reach the floor of the lift. They are asking us to find out. Okay. So one point, let us make the interpretation clearly here. If you look at the stone from the ground frame, with respect to the ground, it will have the initial velocity u in the upward direction and acceleration g in the downward direction. Therefore, as soon as that stone is released from certain height h inside the lift, with respect to the ground, that stone will behave as if it is projected vertically upwards from some height. So the motion of the stone with respect to the ground will be moving upwards and coming back. That is the situation. But when you look at that stone from the lift frame, scenario will be different. Because with respect to the lift, with respect to the lift, let us calculate velocity of the stone and acceleration of the stone and displacement of the stone. All the three factors let us find out first with respect to the lift frame. Okay, here velocity of the stone is the same as that of the velocity of the lift. Therefore, relatively I will write velocity of the stone with respect to the lift will be equal to velocity of the stone minus velocity of the lift. So relative velocity will be equal to 0, very clear. So relatively with respect to the lift, the velocity of the particle is 0. That means the particle is at rest with respect to the lift. So with respect to the lift, that particle moves as if it is released from some height. Okay, this is the interpretation from this velocity part. Now come to the acceleration. Acceleration of the stone with respect to the lift will be equal to acceleration of the stone minus acceleration of the lift. Stone is having acceleration downwards, nothing but g. So this will be g minus j cap. I am using unit vectors. Downwards minus j cap, upwards plus j cap. Minus acceleration of the lift. Lift acceleration is upwards. So this will be a j cap. So the net acceleration of the stone with respect to the lift will be g plus a minus j cap. See, look at this equation carefully, all of you. With respect to the lift, velocity of the stone is equal to 0. It's very clear. And with respect to the lift, that stone is accelerating in the downward direction with a value of acceleration equals to g plus a. It is very clear from these equations. Okay. Then displacement covered by the stone with respect to the lift will be that height h minus j cap. With respect to the lift we are calculating means we are assuming that lift is at rest. If you assume that lift at rest, after releasing that stone has to cover h distance to reach the what we call floor of the lift. It is very clear. So with respect to the lift, in this case, it is very clear that stone is falling downwards from rest with an acceleration value equals to a plus g, and it will cover a displacement of magnitude some 2 meters they have given. So now let us use the kinematic equation. This is a relative frame. They are asking us to find out how much time that a particle will take to reach the floor of the lift. They are asking us to find out. So I use the kinematic equation S bar in a relative frame. So relative displacement will be equal to relative velocity into t plus half into relative acceleration into t square. This equation you can use. Anyhow, relative velocity will be equal to 0. It is very clear. And relative displacement is nothing but h minus j cap, that is equal to half into relative acceleration is nothing but g plus a minus j cap. Therefore, this minus j cap into t square, half into g plus a into t square. So from this equation, it is very clear. Time taken by that what we call that stone to reach. Time taken by that stone to reach the what we call floor of the lift will be given by t is equal to, by solving this equation, that t value will come out to be root of 2h by g plus a you will get. T is equal to that root of 2h by g plus a. H value they have given, g value we know, a value also they have given in the question. By substituting all these values, you can simplify this. It will come out to be 0.61 seconds you will get nearly. See, if lift is laterally at rest, suppose if it is not moving, a man is standing inside the lift and releasing a stone, then it will take a time t is equal to root of 2h by g. That is very clear. So when the lift is moving upwards and also accelerating upwards, and if the stone is released from some height h inside from the floor of the lift, then time taken by that stone to reach the floor of the lift, you can remember equation as t is equal to root of 2h by g plus a. This is the method of taking kinematic equations in relative frame. Come to the next question. The resultant of two forces of magnitudes 1 and p is perpendicular to 1 and equal to 1. What is the value of p and the angle between the forces? Here I would like to convey one important point with this numerical. Whenever if resultant is perpendicular to one of the vectors, definitely the angle between the vectors should be more than 90 degrees. This is a very important point which must be remembered. So in this particular example, if you look at this case, one force is acting along x-axis, p bar as a vector, its magnitude is given 1. Another force is having a magnitude p, and the resultant of these two forces will have magnitude 1, and that resultant is making an angle of 90 degrees with 1. That is the case they have given. So resultant is making, this is resultant r bar, its magnitude is 1, which is making an angle of 90 degrees with the first vector. Definitely that second vector should come like this, q bar. So if resultant makes an angle 90 with one of the vectors, the angle between these two vectors definitely it should come out to be more than 90 degrees. So here q bar magnitude is given p. Okay. So here this is q bar of magnitude p. So from this diagram it is very clear. P square seems to be like hypotenuse. P square will be equal to 1 plus 1. So P will be equal to root 2 newtons you will get directly from the diagram. It is very clear. Along with this the value of P, they are asking us to find out the angle between P bar and Q bar. So taking angle between the two vectors also really it is very important. Here this is the direction of the P bar. If you look at the diagram, this is P bar direction. Q bar will be like this. So the angle between P bar and Q bar means this is the angle between P bar and Q bar, theta. This angle you can calculate from the triangle very clearly. This angle. This angle you can, otherwise if you think the diagram separately for this part, our requirement is this angle, theta. This value we got it as root 2, this is 1, this is 2, this is alpha if you take. From the diagram we can take sin alpha will be equal to 1 by root 2 or tan alpha will be equal to 1 by 1. That alpha will come out to be equal to 45 degrees. 45 degrees is not the angle between P bar and Q bar. The angle between P bar and Q bar is nothing but theta. Theta is nothing but, in this case, theta will be equal to 180 minus 45 degrees. So, 135 degrees is the angle between P bar and Q bar in this case. So, for this particular question, first option will become the answer. Come to the next question. This question also has given in previous 2021, not 21, I think it is 2019 Neet entrance examination. The speed of a swimmer in still water is 20 meter per second. Speed of a swimmer in still water means it is velocity of the swimmer with respect to the river. The speed of the river water is given and is floating towards east. If he is standing on the south bank and wishes to cross the river along the shortest path, the angle at which he should make his strokes with respect to the north is given by. So just look at this case, all of you. In this case, that man has to reach exactly opposite points. Already we have discussed this basic concept. To reach exactly opposite point, velocity of the boat with respect to the river should make some angle theta with the vertical like this, and he is reaching exactly opposite point. See, carefully look at this example. They are asking the angle at which he should make his strokes with respect to north they are asking. That means west of north angle they are asking us to find out. See, already I told you this is the north direction, this is west direction. West of north means actually the angle what I have defined in the diagram only the required angle, theta. That theta they are asking us to find out. Okay. So here velocity of the boat with respect to the river is nothing but, or velocity of the man in this case with respect to the river, value is given 20 meter per second. This value is 20. And river velocity they have given as value 10 meter per second. This is the river velocity, VR bar, 10. So from the diagram it is very clear, sin theta will be equal to VR divided by velocity of the man with respect to the river magnitude. So this will be, it is very clear, 10 by 20, nothing but 1 by 2 theta is coming out to be 30 degrees. If you do not have proper idea relating to these directions, sometimes you may commit mistakes in the competitive exams. So here 30 degrees will be the answer. 30 degrees means it is west of north. So first option will become correct option. Come to the next question. To a man walking at the rate of 3 kmph, the rain appears to fall vertically. Rain appears to fall vertically means it is appearing like that. It is not actually falling vertically downwards. Okay. When he increases his speed to 6 kmph, it appears to meet him at an angle of 45 degrees with the vertical. Find the speed of the rain. Okay. Initially, it is not raining actually vertically downwards. It is raining something like this. This is the velocity of the rain, original direction. For that rain appear to be hitting that man vertically downwards means that man should move in the forward direction. Already we have seen, if man moves in the forward direction, the train appears to be tilted away from that part. So in this case, this should be the velocity of the man in the first case, and his speed is given 3 kmph, 3 units, 3 kmph. So by the vector diagram, what we have discussed, velocity of the rain with respect to the man, velocity of the rain with respect to the man is the resultant of two velocities, velocity of the rain plus minus velocity of the man. Okay. So in this case, for this man, the train appears to be falling vertically downwards. So this is minus Vm bar. Here also majority of the students generally they undergo some confusion relating to some basics. The magnitude of Vm bar is 3 and the magnitude of minus Vm bar also will become 3. Both will have same opposite vectors, have same magnitude, only opposite in direction. Okay. So here this is the velocity of the rain with respect to the man in the first case when he is moving with 3 kmph. When he increases his speed from 3 kmph to 6 kmph, the train from vertical direction still it will be tilted away. Initially it is falling with some angle. When he starts moving with some speed 3 kmph, it has become vertical. Still if he increases his speed to 6 kmph, that rain will be tilted away. So just look at this diagram for the second part. It is original direction, VR bar. Now he has increased his speed to 6, double as that of the previous case. Now that the total vector length has become 6. Minus Vm bar you take other side. You just extend the same length to the other side. This is minus Vm bar and its value is coming out to be 6. Okay. That means this is the situation they have given now. This is velocity of the rain with respect to the man. With the vertical, it is making an angle of 45 degrees they have given in the question. Okay, so from these two diagrams, if you compare both the diagrams, second diagram with the first diagram, if you compare, you can divide this 6 into 2 parts. This is 3. This 3 you can compare with the previous diagram 3, same. So this is the vertical side, this is the vertical side. If this is 45 degrees means other also will become 45 degrees. Therefore, this side 3 means this vertical side will become 3. Our requirement is calculation of speed of the rain. Speed of the rain means speed of the rain will be in this hypotenuse. If you take a separate triangle for this particular part, this is the speed of the rain. This is 3, this side is 3. So speed of the rain will be equal to root of 3 square plus 3 square. Nothing but 3 root 2 meter per second is the speed of the rain. Come to the next question. A particle moving in a circle of radius r with a uniform speed takes a time t to complete one revolution. If this particle were projected with the same speed at an angle theta, it is misprinted, theta to the horizontal, the maximum height attained by it equals to 4r. The angle of theta is then given by. This also given in 2021 NEET entrance examination. So initially it is moving in a circular path with some constant speed. Therefore, t is equal to 2 pi r divided by u. We can take time period of rotation is t. R is the radius of the circular path they have given. From this you can calculate the value of u. U will be equal to 2 pi r by t. Okay. With the same speed, if that particle is projected obliquely, how much maximum height that particle will reach, that they are asking us to find out. In case of an oblique projection from the ground, the maximum height attained by the body will be given by u square sin square theta by 2g. Actually maximum height they have given, not maximum height. They are asking us to find out angle of projection. Maximum height they have given as 4r in the question. maximum height is given 4r. U value you can take from this first equation. So automatically you can calculate the value of theta. By substituting all these values, you will get the angle of projection. Come to the next question. This question has given in recent NEET entrance examination 2022. A ball is projected with a velocity 10 meter per second at an angle of 60 degrees with vertical direction they have given. Its speed at the highest point of its trajectory will be. So regarding this type of numericals, sometimes students they are committing mistake by assuming that angle with horizontal direction. As a standard case, by taking an angle with horizontal, they practiced all the equations. But in this case, it is given. Be careful regarding this type of questions in the examination, that 60 degrees with vertical they have given. This is theta with vertical. They are asking us to find out the velocity at the highest point. This time, horizontal component of velocity will become u sin theta, it will become horizontal component. And they are asking speed at the highest point. So at the highest point, net velocity will be equal to horizontal component of velocity only. Vertical component of velocity will become 0 at the highest point. Therefore, the net velocity at the highest point will be equal to u sin theta. U value is given 10. Sin theta is nothing but 60 degrees. So 5 root 3. 5 root 3 meter per second is the velocity at the highest point you will get. Okay, look at this part. From a tower of height 19.6 meters, two bodies are simultaneously projected horizontally in opposite directions with velocities 1 meter per second and 4 meter per second respectively. The time taken for the velocity vectors of two bodies to become perpendicular to each other, they are asking us to calculate. I have taken this simple numerical to explain one important point. If two vectors are perpendicular to each other, their dot product will be equal to 0. So here, so this question is based on that concept, and the other part is relating to that projectile. Here, just look at this diagram, all of you. One particle, you just assume, projected along positive x-axis with a speed 1 meter per second. Another particle is projected simultaneously from the same point in opposite direction, negative x-axis, with a speed they have given 4 meter per second they have given along negative x-axis. See, very interestingly, we know that when a particle is projected horizontally from the top of the tower, time taken by the particle to reach the ground will be same, but they will cover different ranges. One will move in a parabolic path of some range like this. Other will move in a parabolic path of more range it will cover. This range will be more in comparison to this range. So in this case, they are asking us to find out after which time the velocities of the two bodies will become perpendicular to each other. So velocity of this first body is, say for example, v1 bar. Velocity of the second body will be like v2 bar. For these two velocities to become perpendicular, their dot product should be equal to 0. First of all, let us calculate these velocities by using kinematic equation, general kinematic equation. V bar is equal to u bar plus a bar into t. If you apply this equation to the first particle moving along positive x-axis 1 meter per second, it is I cap, 1 I cap, velocity is 1 I cap plus the acceleration is downwards, g minus j cap, g minus j cap into t. This is v1 bar, velocity of the first particle. Come to the velocity of the second particle after time t. It is projected along negative x-axis. So 4 minus I cap, negative x-axis minus I cap plus g minus j cap as it is, acceleration is downwards into t. These two velocities have to become perpendicular to each other. So for the, you can perform dot product between them. v1 bar dot v2 bar is equal to 0. By performing dot product between them and solving that equation, you will get time taken for those velocities to become perpendicular with each other will come out to be 0.2 seconds. Look at, two more questions are left over. Just look at this part. A car is moving with a speed of 30 meters per second on a circular path of radius 500 meters. If its speed is increasing at the rate of 2 meters per second square, the net acceleration of the car, they are asking us to find out. So you should be very careful regarding this type of questions also. A car is moving with a speed 30 meters per second on a circular path of radius 500 meters it is given, and speed is increasing at the rate of 2 meters per second square. Speed is increasing at the rate of 2 meters per second square means the 2 meters per second square represents tangential acceleration of the particle. Only tangential acceleration is responsible to change the speed of the particle. So in this question, tangential acceleration is equal to 2 meters per second square. They are asking us to find out the net acceleration of the particle. If there is a tangential acceleration in circular motion, definitely that circular motion comes under non-uniform circular motion. In non-uniform circular motion, the net acceleration of the particle is the resultant of tangential acceleration and radial acceleration. Radial acceleration, another name is centripetal acceleration, which will be given by v square by r. V is given 30 whole square divided by r value they have given 500 meters. From this you will get radial acceleration. They are asking us to find out the net acceleration of the particle. So net acceleration will be root of a r square plus a t square. By substituting this AR values in this equation and by solving that equation, the answer will come out to be 2.7 meters per second square. One more simple question I discussed, with that I will conclude today's class. The speed of a motor decreases from 1200 rpm to 600 rpm in 20 seconds. The total number of rotations it makes before coming to rest is, okay. See, just like linear kinematic equations, we are having rotational kinematic equations also, if angular acceleration of the particle remains constant. If angular acceleration of the particle is constant, if alpha is constant, just like linear kinematic equations, rotational kinematic equations also you can practice, like omega 2 will be equal to omega 1 plus alpha into t. Similarly, theta will be equal to omega 1 into t plus half alpha into t square. Omega 2 square minus omega 1 square will be equal to 2 alpha into theta, so on like that we can take when alpha is constant. Okay, in this case they are asking us to calculate the total number of rotations it makes before coming to rest. Okay, here they have given angular speed they have given, omega 1 will be equal to 1200 rpm they have given. Let us convert this rpm into rps I will calculate. I keep rotations as it is because final result we have to get in terms of rotations only. So rotations per second I will make. So this will be 1200 by 60 rotations per second. So this will be 20 rps. Similarly, omega 2 will be equal to 600 rpm they have given. This rpm also I will convert into rotations per second. I will convert by dividing with 60. 600 by 60 rps, nothing but 10 rps. That is omega 1. That is omega 2. Okay, first of all, the angular speed is changing from 1200 rpm to 600 rpm or 20 rps to 10 rps in 20 seconds. From this, let us find out the value of alpha. Alpha will be equal to omega 2 minus omega 1 divided by t. As it is constant, we can take. So, so from this we will get 10 minus 20 divided by time is given 20. So this will be minus half rotations per second square you will get. So this is alpha value. Alpha is negative, means the body is undergoing angular retardation. How much time, how many rotations that the body makes before coming to rest, they are asking us to find out. So we can take this third rotational kinematic equation. Here omega 2 square will be equal to 0 minus omega 1 square is nothing but 400 will be equal to 2 into alpha value will be minus 1 by 2 into theta. Then the value of theta directly you will get in rotations. Theta will be equal to 400 rotations. So I am concluding today's class with this particular numerical. So before you are going to attempt this competitive examination, this NEET, get ready with all the concepts and equations from the all chapters. Thoroughly just prepare and prepare those applications also very clearly. If time permits, once again we will meet in another video with a new topic. Okay, wish you all the best.